Today, we'll be applying what we know about lines and angles in order to classify 2D shapes. When we're classifying shapes by lines, we'll be talking about the sets or pairs of perpendicular lines, parallel lines, or intersecting lines that we have in a shape. We're going to be focusing on parallel and perpendicular lines. Remember that parallel lines never touch. So these sets of lines are the same distance apart all the time. They will never touch no matter how far they go, just like the two L's in the word parallel. Perpendicular lines intersect or cross at a 90-degree angle. And mathematicians put this little box in the corner to show that it's a 90-degree angle. So if you see that, you know you have perpendicular lines and you know you have a right angle. We classify based on the number of sets or pairs of parallel or perpendicular lines. So remember we talked about a set or pair of lines includes how many lines? Just like a pair of socks, it includes two lines or two socks. So 2D shapes could have 0 sets of parallel lines, 1 set of parallel lines, 2 sets of parallel lines, and so on. So let's think about where we would put these different shapes. If I get out my little laser pointer and I look here, I'm looking for lines that will never cross. Hopefully you're looking and you're like, Miss Hershey, I see it. I would raise my hand if we were in class. Parallel lines. So we're going to be looking most of the time at like the top and the bottom and the sides. I see here the top and the bottom. Are those lines ever going to touch if we go forever in both directions? Or what about these sides? Are they going to touch? I look here. I'm thinking, are these top and bottom parallel? Are these sides parallel? Then if I look at this, it's got 1, 2, 3, 4, 5 sides, so it's a pentagon. Are there any sides that I could continue in any direction and they would never touch? So this pentagon had 0 sets of sides. They're not going to touch at all. This trapezoid, the top and the bottom are parallel. That's 1 set. You need 2 lines to make 1 set. But the sides, if we continued these sides, they would go up and they would hit each other. So that wouldn't work. And then if we look here, the sets of parallel lines in a rectangle, the top and the bottom are parallel, that's 1 set, and the sides are another set. So that's 2 sets of parallel lines, and all rectangles have 2 sets of parallel lines. Now we'll classify 2D shapes based on the number of sets or pairs of perpendicular lines. So we've got 3 new shapes. This looks like a square. Remember, when I'm counting sets of perpendicular lines, I'm looking for right angles. Any right angle that you count is a set of perpendicular lines. So where do you think this red square would go, this green triangle, or this white trapezoid? Count how many right angles it has so that you can classify it. So this triangle has 3 acute angles. None of these lines create a 90-degree angle, so it has 0 sets of perpendicular lines. This trapezoid, I can see it has 2 right angles, and the top line and the side line that I've traced in blue, those 2 lines are a set of perpendicular lines. And then the side and the bottom in yellow are another set of perpendicular lines. So that's 2 sets. And then our square here has 4 right angles. And 4 right angles means 4 sets of perpendicular lines. We can also classify 2D shapes based on their angles. When we're talking about angles, remember we can have an obtuse angle, an obese, fat angle. We could have a right angle that's right on 90 degrees. Or we could have a cute little angle that's less than 90 degrees. When we're classifying triangles based on their angle, there's actually three types of triangles: an acute triangle, a right triangle, an obtuse triangle. And what we do is we classify them based on their largest angle. So in an acute triangle, the largest angle is acute. So all the angles have to be acute. And we can see, here's an example. A right triangle, its largest angle is a right angle, is 90 degrees. That means the other two angles have to be acute because they're smaller than a right triangle. So it'll have one angle that's right and the other two have to be acute. The last type is an obtuse triangle. So it'll have one very big obtuse angle and the others will be acute. They'll be little. So we can see here we've got 110 degrees, it's obtuse, and then we've got two smaller angles here. This is just a fun fact, not something you need to know in 4th grade, but if you add up all the degrees inside a triangle, you get 180 degrees every single time. So if this is 110, that means this angle plus this angle has to be 70 degrees because 110 plus 70 would be 180. So the two other angles together would make 70. So that's how you know they're acute as well. So all the angles in a triangle make 180 degrees. Fact. So how would you classify this triangle? I can see it's got this special little square in there. And remember, that's a hint. That means it's a right angle. Right angle, right triangle. What about this one? I see I've got 3 different degrees, 59 degrees, 66 degrees, and 55 degrees. How would you classify that triangle? All of those angles are acute. So if all of them are acute, it's going to be an acute triangle. What about this one? Well, this one looks pretty acute. This one looks pretty acute. This one looks honestly similar to a right angle, but it's bigger. And if we were in class, I'd put my piece of paper up in the corner and be like, ooh, I know that's greater than 90 degrees. That means this is an obtuse triangle. Now, how would we describe this shape? So, what kind of shape is it? What do you observe about the angles? I notice that there's 1, 2, 3, 4, 5, 6 sides. So this is a hexagon. It has 1, 2, 3, 4, 5, 6 obtuse angles. So we could write that. That's what we observe about the angles. I observe that they're all the same size. I also observe that there's some parallel lines here because this side and this side are never going to hit. How many sets of parallel lines are there? 1, 2, and 3. 3 sets of parallel lines. How would we describe this shape? So sometimes when we're observing, we're not like classifying and saying it's an obtuse triangle. Well, we do that, but we don't do that with other shapes. We just observe what the other angles are. So here, this is a parallelogram, and we would just say this parallelogram has, well, angle B and angle D both look big to me. So this parallelogram has 2 obtuse angles, angle B and angle D, and 2 acute angles, angle A and angle C. All right, now we've got a pentagon, and I'm noticing all of these angles are obtuse again. We've got 5 sides with 5 acute angles. They look like they're about the same, which is interesting. All right, now I have another pentagon, 5 sides. What's different about this shape and the last one? Well, the last one, all the sides are the same length and all the angles were the same. That was called a regular pentagon. This is an irregular pentagon. And I noticed this one has 2 right angles, 2 obtuse, and 1 acute angle. So I'm just modeling how you might describe shapes based on their angles and lines. And we could also say here, if I have 2 right angles, that means I have 2 sets of parallel lines. This shape, okay, a regular octagon, all of these angles are 135 degrees. They are obtuse. Which statement about these 2 figures appears to not be true? So now we're observing and describing about both figures. Okay. I see I've got a hexagon and 1, 2, 3, 4, 5, 6, 7, 8, and an octagon here. Both shapes have parallel sides. Both shapes have obtuse angles. Both shapes have acute angles, or both shapes have intersecting lines. Remember, which one is not true? So let's check them. F, both shapes have parallel sides. Already I can see boom, boom. Now there are more sets, but I already found one, so I don't really need to check it. And I gotta check both shapes, boom, boom. So not F. Wait, yeah, because that is true. We're looking for not true. G, both shapes have an obtuse angle. Okay. Does that angle look bigger, larger than 90 degrees to you? What about this one? Both of those, all of these angles are obtuse. So this is true, so it can't be the answer. Both shapes have acute angles. Okay, well I said this one was obtuse. Does this look acute, obtuse, or right to you? If I look at all these angles. Same here. I think they're obtuse, so I'm going to put a dot next to that because that does not seem true. Both shapes have intersecting lines. Intersecting lines. Those are just lines that cross. Do these have lines that meet and cross? Yeah. Cross, cross. Anytime you have a corner, you got intersecting lines. So that's true. So it can't be that. So it's gotta be H for Hershey. Next practice, a figure is shown below. Which 2 line segments appear to be parallel? Okay, I'm looking for line segments that never touch. I also note that I need to name these using the letters. Okay, line segments HO and KL. So HO, KL. This one looks straight up and down. This one seems to have an angle on it. Like if I went down here forever, I think they would cross. So that's not going to be it. B, HO and IJ. Are those parallel? No, they'd cross like right here. Line segments HI and NO. HI, hi, and no. Parallel, if I continue those, are they ever going to touch? These are terrible drawings of lines. I don't think they're going to touch, so I'm going to put a dot. And lastly, line segments IJ and MN. IJ, NM. Ooh, those are close. Honestly, looking from here, it's hard to tell. If I was watching this video on a phone, I'd probably think that this was also parallel, but I can tell you as your teacher that this one bends a little bit more, so eventually it would take a while, but they're going to cross up here. So it's not going to be D, and it's going to be C. Line segments high and no. How many pairs of parallel lines does the figure below have? Pause here and play when you're ready for the answer. We can see that the top and bottom are parallel and all the other sides will intersect, so there is only one set.